all. Good morning, my good listeners. If you see this video, please do me a favor by commenting on it, like it, as well share. This is KINGSOFT online tutorial class. Today we'll be talking about complex numbers, and we have a question that is lifted from the equality of complex numbers. That is where this question is being lifted from. But before I solve this question, I will first of all want to explain to you what a complex number is all about. Now, when we talk about complex numbers, we mean a number that is written in the form a plus bi, where a is the real part, bi is the imaginary parts. Now, this I is the imaginary unit, and this imaginary unit has a value of root minus 1. Now, for those of you who are doing electronics and electricity, if you want to denote this imaginary unit, you rather use J, because already I is the symbol for current. So you use J if you are doing courses in electronics and electricity. But if it is mass, you are free to use your I. And this I is denoted with root minus 1. Now let us now go to this. We are talking about the equality of complex numbers. Now when we say the equality of complex numbers, two complex numbers are said to be equal if the real parts are equal and also the imaginary parts are equal. For instance, let me demonstrate it. Given a complex number z1 equal to a plus bi, and another complex number z2 equal to c plus di. These are two different complex numbers. We say they are equal if a is equal to c and b is equal to d. In this case, we will now conclude that z1 is equal to z2. So the two complex numbers are equal. We are now going to use this idea to solve this problem, because this problem is lifted from the equality of complex numbers. Just as I said, we have known the meaning of complex numbers. We have also known the meaning of the equality of complex numbers, where this question is being lifted from. So for us to solve this, we say solution. Equating the real parts. That means we are going to start by equating the real parts. And the real parts here are 6 and 3x. We equate them, we make them equal. So we have 6 equal to 3x. And remember, we are looking for the value of x. We now divide both sides of this equation with the coefficient of x, which is 3. So that we are going to have 6 divided by 3 equal to 3x divided by 3. 3 cancel 3, x becomes equal to 6 all over 3, which is equal to 2. So our x is equal to 2. Then for us to get y, because we are asked to find x and y, for us to get y, it means we are going to equate the imaginary parts as we equated the real parts. Let us now equate the imaginary parts to get y. To do this, we say equating the imaginary parts. The imaginary parts here are the 14i and the 2yi. So in this case, I will cancel I, no need of rewriting it again. So that we are going to have a 14 equal to 2y, making y the subject of the formula, just as what we did here. We made x the subject of the formula here and we obtained 2. So making y the subject of the formula, we now have y equal to 14 all over 2, and y is equal to 7.